Assalamualaikum warahmatullahi wabarakatuh. My name is Raditya Pangestu. I am from 11.8. My number is 21 and I make this video to presentation about gamma rays. I apologize if I have some mistakes when I speak English language, especially in my grammar and pronunciation. So, let's start to the presentation. First, I want to explain about definition of gamma rays. Gamma rays, also called gamma radiation, is electronegative waves that come from the excitation and electronic de-excitation. Gamma was coming from the word of atom core. Gamma rays denoted by the lowercase Greek letter gamma. Next, about spectrum of electromagnetic wave. Gamma rays cannot be penetrate Earth's atmosphere, but can damage Earth's atmosphere. Gamma rays typically have wavelength less than 10-12 degrees meters, and gamma rays typically have frequency above 10-20 degrees up to 10-25 degrees Hertz, and the temperature of objects at which this radiation is the most intense wavelength emitted more than 10 billion Kelvin or degrees Celsius. Next relevant figure. The first man who discovered gamma rays is Antoine Henry Becquerel. I am sorry if I am wrong when I spell his name. In the end of 1890, Becquerel discovered radioactivity in atmosphere. He covered the uranium salt by using thick black paper and put it on the photographic plate, and then he put it into the drawer without exposing it to sunlight first. A few days later, he found that the photographic plate shows crystal shadows. He speculated that the radiation is stronger than the X-ray. Next, the man who discovered gamma rays is Paul Ulrich Villard. Gamma ray is discovered by French chemist and physicist Paul Ulrich Villard in 1900 while studying the radiation emanating from radium, polonium, and uranium. He finds that gamma ray cannot be deflected by magnetic fields. Next, there are Ernest Rutherford and Edward Neville da Costa Andrade. In 1914, Ernest Rutherford and Edward Andrade showed that gamma rays were a form of electromagnetic radiation. The wavelengths were similar to those of X-ray and are very short. It was Ernest Rutherford who named gamma rays. Rutherford had previously discovered two other types of radioactive decay, which he named alpha and beta rays. Selanjutnya mengenai mekanisme dari sinar gamma. Sinar gamma umumnya hampir sama seperti sinar X, tetapi sinar X itu lebih lemah. Sinar gamma dapat dihasilkan oleh bahan radioaktif. Lalu sinar gamma juga tidak dapat dilihat oleh mata, oleh karena itu diperlukan detektor. Detektor ini digunakan untuk mendeteksi sinar gamma. Cara kerjanya, apabila sinar gamma mengenai detektor, maka akan terjadi 3 efek, yaitu efek fotolistrik, Compton, dan bentukan pasangan. Efek fotolistrik ini terjadi apabila ada sinar gamma yang mengenai elektron di kulit K dari sebuah atom, maka elektron tersebut akan kosong sehingga akan diisi oleh elektron dari kulit lain. Transisi ini yang menyebabkan terjadinya efek fotolistrik. Lalu efek Compton adalah efek yang terjadi apabila sinar gamma dalam hal ini mengenai elektron bebas atau elektron terluar dari suatu atom yang dianggap daya ikatnya sangatlah kecil sehingga sama dengan elektron bebas. Apabila sinar gamma memancar ke elektron bebas ini, maka akan terjadi hamburan yang disebut hamburan Compton. Sedangkan efek bentukan pasangan terjadi ketika sinar gamma melaju di dekat inti atom, sehingga akan terbentuk pasangan positron dan elektron. Syaratnya tenaga sinar haruslah cukup. Next, about application of gamma rays. Gamma rays used for radiotherapy to cure cancer, tumors, and other disorders. Under normal circumstances, human cells will develop by dividing themselves, as well as cancer cells. But these cancer cells divide too fast and are abnormal. Cancer cells occur because of normal cells that mutate. This radiotherapy serves to damage the DNA that regulates the division of cancer cells. Gamma rays will emit directly on cancer cells to destroy or kill. Normal cells will be affected by side effects, but only when do the therapy. Next, gamma rays used for kill microorganisms or sterilization. Because gamma rays have high energy and penetrability, gamma rays can be used to sterilize food, drinks, and surgical equipment. Before that, objects to be sterilized are placed in a container and then passed under gamma rays to kill microorganisms found in the object. This doesn't affect the content in food or drink, it only kills microorganisms, so that food or drink will have a longer durability and is certainly safe for consumption. Next, gamma ray used for formation of superior seeds. Gamma rays used to change the structure and properties of chromosomes in plants to produce a better generation. It does by irradiating cells and tissues in plants so that mutation occur as in the number of chromosomes or gains in the cell nucleus. From the mutation process, seedlings plant and can produce beneficial properties such as rice plants that are resistant to pest attacks. Next, gamma rays are used for tracking underground pipeline leaks. By using Psi-6, especially gamma ray electromagnetic waves, we can detect leaks in a pipe buried underground, a substance that can emit gamma rays. Sodium number 24 in the form of carbonate is dissolved in water and run in underground pipes. Then the soil surface above the pipe is checked with Geiger-Müller. Excessive radiation intensity illustrates the leak in the pipe. Next, gamma rays are used in vulcanizing natural latex or examining metal defects. Our tendency is assuming that when the metal solidifies to form a crystal lattice structure which is very organized, there is no defects in the composition of the pile. Actually, no. Metals always have imperfection called defects. The lattice structure, and this is often very influential on the nature of metal cohesion. Metal grain structure caused by compaction during molding process, and also influenced by mechanical threat received during the construction and fabrication. Malleable nature owned by the metal means that the process can lead to change in shape that are not grooved in the grains and cracked or broken in parts or lattice that formerly perfect. Last, about conclusion. The conclusion in this presentation is gamma rays are electromagnetic waves derived from excitation and the excitation of electrons. Gamma rays occur because of the decay of the atomic nucleus. Gamma rays have the shortest wavelengths and are the longest compared to other electromagnetic waves. And I think it is enough. Thanks for your attention. Ya, you. Wassalamualaikum warahmatullahi wabarakatuh.